So welcome to the IRIS Mission Operations Center. Jim is our Mission Operations Manager. My name is Robert. I'm one of the flight controllers. Eddie here is another flight controller. Darren is one of our systems engineers, and Brian is our NMOC support team. He supports the Multi-Mission Operations Center, which includes both IRIS and LADEE, as well as Kepler and others. This room is where we run the IRIS spacecraft from. We launched about a month ago. We're a solar observing satellite. We're in low Earth orbit, a polar orbit, so we can always see the sun. And our goal is to study the sun, the energy transfer from the chromosphere to the corona of the sun, looking at the ultraviolet frequencies. We've just posted some of our first images, which I think Jim is trying to bring up on the screen. There we go. Okay, so up over there on that screen, you can see the image on the right is one of our first images, and the one on the left is an SDO image. SDO is an existing satellite. They've been looking at the whole sun. They image the whole sun constantly. And what we do is focus in on particular areas and try and understand more detail of what's happening in those particular areas. The room down over here, and you should all rotate by as you can, is where they built the LADEE spacecraft. You'll actually see inside the clean room tent that there's a movable fixture, and that's what they had the LADEE spacecraft mounted on for assembly. So feel free to drift by the window there and take a look at what's going on there. We're doing still checkout operations on IRIS. We've got about a month now that we've been flying, and things are starting to settle down, but we're still trying to figure out some things in terms of calibration of the attitude control system and so on. And do you all have any questions?
How many days is this mission?
60 days, and so we're about 30 days in.
Spent about 30 days basically checking out the telescope on board and the rest of the spacecraft itself, and then we spend about 30 more days doing science calibrations. So, like you see here, we're comparing our imaging with SDO's imaging, for example. And Hinode is coming around out of eclipse, so we're going to be doing some correlation work with them as well.
How often do you talk to IRIS?
6 times a day right now, right?
Oh, wow.
Yeah. We just finished a command pass about 20 minutes ago, and we've got another one coming up in about an hour.
IRIS talks, it's in a polar orbit. It goes over the North and South Pole, which means it just goes around the North and South Pole, and it's looking at the sun all the time, so it's kind of doing this sort of thing. And it goes around, it talks to the Earth 14 times a day. We talk to it 6 times a day. Us talking to it, it's just us sending commands up to it, which are basically putting timelines on board that acquire these images and make sure the spacecraft health is good. And it's downloading data all the time.
No, we're using mostly the near-Earth network, which is ground-based satellite dishes. We're using Svalbard, Alaska, Wallops, and McMurdo ground stations.
So then in KSAT.
Yeah. KSAT is the Norwegian company. They run Svalbard, and we're using them as well.
You guys are lunar people, right? Sort of, kind of, something. At any rate, when Rusty talks to you about LADEE, they're going to be using some of the same networks that we are, but they're also using the Deep Space Network. So that's Madrid and Canberra, Australia, and Goldstone down south. Anytime you get a little ways away from the Earth, the further away you go, the bigger the antenna you need to find the spacecraft.
Any other questions? Well, I know Rusty's got some more exciting stuff to show you, so I don't want to keep you. So feel free to head on out. Like I said, drift by the window on your way out.
Thank you. Just to start out, hi, my name's Rusty. I'm one of the flight directors for LADEE. We have a test going on right now that has some spacecraft data up, so please don't take any pictures into that room.
Okay, cut off you.
So you come down here though, go ahead and look in the room. This is this is called the Mission Operations Control Room, or LADEE. It's one of 5 rooms that we have here that we perform operations out of. This is where we do the real-time operations. We get the telemetry down from the spacecraft and we send the commands up to the spacecraft. Off in that corner over there is where the flight director, where I sit, and direct the activities for whatever's going on. The 2 people there are called data engineers. They interact with the Deep Space Network antennas that are around the globe. which is what they're doing right now. We're doing a test with a deep space station in Madrid, Spain. It was one of the stations we'll use during flight. They're sending data to us. We're making sure we can get it and send commands to the station. We do quite a few of these tests before we launch. Then in the middle here, systems engineers sit here and monitor all the systems on the spacecraft. Over in this end is the project manager and the mission ops manager will monitor all the activities of the flight. And then we have these monitors around the room looking at we got graphs of different spacecraft parameters and a little thing there that shows which stations we're connected to. We connect to 2 different DSN ground stations and also one of the TDRS flying satellite stations at the same time, and we switch between them. Let's see. So that's what's in the control room. I don't know what else you've heard about today. Do you know about LADEE? Should I talk about LADEE a little bit? Okay, because I drew pictures of our, like our orbits and stuff, and we're gonna, fly around the moon. Did they tell you about laser communications?
Yeah. A little bit.
Yeah, okay. So lasercom is one of my favorite parts. So we have 4 different payloads on LADEE. 3 of them are science instruments, and one's a laser. Lunar laser communications demonstration, and it's a 2-way laser that's on the spacecraft. There's 3 different ground terminals on Earth, and we're testing a new doing communications over laser as opposed to RF, and we'll be able to get like 10 megabits per second communications rates over the laser versus the best we can get usually is maybe about 1 over RF. So that's that'll be a great improvement. We'll really just get 10 or 100 times more science data down on the missions that we run. Let's see, what else? Do I have 5 minutes left, should I?
Like 3.
Yeah, okay, do you have any questions about LADEE?
So it's making 3, is it 4?
Tell us about that.
Yeah.
Okay, yeah.
That's the mission plan?
So we launch on a Minotaur 5 rocket, which used to be some missile war thing. So now we're launching science with it. It can't quite get to the moon in one shot. So we do a series of loops, and this is kind of what it looks like over time. If you look at it like in space, it would be loops like this, and as the moon's going around. And by the time we get after the 3rd loop, when we come back around again, the moon's right there. So anyway, we have a series of apogee and perigees, 3 apogees, 3 perigees. And what we do when we pass each one of these perigees, we fire the thruster and raise the apogee. And so we'll do that 3 times and come around, and at just the right time, we'll come up and we'll intersect with the moon, and we fire the thruster again here right after we come around the moon and slow down, and then that'll put us into orbit around the moon. And it's another elliptical orbit, and we do 3 more maneuvers over about a month to lower ourselves down to our final science orbit, which is a very low orbit of about 50 kilometers above the surface. So anyway, so that's what we do. This is our first about 3 weeks in the mission. Then we spend another month here, and then finally we get into the science phase, which is about 100 days.
Are those burns automated?
They are sort of. We load them on the spacecraft from the ground. We have, that's what the rooms downstairs do, is they're the whole orbit determination and planning, and they build command sequences, and we load the sequence on the spacecraft the day before the maneuver. And actually, if we lost communications, then it would perform nominally.
Right.
Although we do have communications all through here in case there's problems. We also, when we're coming down here, most of the way in, we're on the Deep Space Network dishes that are good for pointing at the moon or Mars or way out in space. But we get so close to the Earth, we actually come inside the orbit of like geosynchronous satellites. And we get down so low, DSN, we're moving too fast for DSN to track us, so we switch over to something called TDRS, which is what the space shuttle used for their communications. And so we come in, we switch from DSN to TDRS, monitor that for about a half hour as we're swinging along and doing our burn, and then we switch back over to the Deep Space Network on those. We're, in fact, actually next week we're doing an operational readiness test, and we'll practice that, the whole sequence with the team and with the ground stations. Good questions. What else? Okay. So we fly around the moon. It's called a retrograde orbit. So the moon's going, if you're looking down from the North Pole, the moon's going around this way. And we will orbit the moon in this direction. And as the moon's turning, there's this side back here that's in the shadow of the sun. Here's my sun up here. And so it's very cold, very dark back here. And things from space land here, including some things that become volatile when they're hot. And right here where the moon turns around and this piece of ground turns into the sun, it goes from very cold to very hot really quickly. And all this stuff bounces up, it flies up off the surface of the moon then. And we're gonna fly down here, 50 kilometers above the surface, and we'll fly through this every time we go around. Our orbits are about 1 hour. So once an hour, we'll fly through this terminator, and every time we fly around, the moon will have turned a little bit, new patch of ground will come into the sun, and new stuff's flying up. And we have these instruments to measure the neutron mass spectrometer to see what's in the particles, ultraviolet spectrometer to look through. As we're flying through, actually they tend to look back here on the Sunset Terminator, looking back through what's been flying up and see what it looks like with the sun shining through it. And then LDEX, which is the Lunar Dust Experiment, which actually counts how many particles it's passing through. And so that's what we're doing.
Thank you so much.
You bet.
You have to run right now, but
Okay.
thank you so much.